Megan.
So, thanks and welcome to everybody who's joining us for today's seminar in our Fall 2021 GES seminar series. And today we have Dr. Matt Fagan. I think most everybody here knows Matt, and he's a faculty member in our department. And I'm going to introduce Megan Fairfield-Peak, who is actually going to introduce our speaker.
Great. Thank you so much, Dr. Miller. Hello and welcome, everyone. My name is Megan Fairfield-Peak, as Dr. Miller just mentioned, and I'm a first semester master's student here at UMBC, and I'm honored to introduce my mentor and our speaker today, Dr. Matthew Fagan. Dr. Fagan received his undergraduate degree in ecology, evolution, and conservation biology from the University of Texas at Austin. He went on to get a master's degree at Dartmouth College, where he studied the impact of the invasive shrub glossy buckthorn, on tree seedling recruitment. After Dartmouth, Dr. Fagan spent several years working for the Nature Conservancy, as well as a high school biology teacher, before starting a PhD at the E3B department at Columbia University with Ruth DeFries. His thesis work focused on land cover change and functional connectivity in the San Juan, La Selva biological corridor in northern Costa Rica. Dr. Fagan then did a postdoc with Doug Morton at the NASA Goddard Biospheric Sciences Lab before starting as an assistant professor here at UMBC. Today, Dr. Fagan will be presenting The Forests We Need, The Forests We Create, Restoring a Degraded Planet with Ugly Maps and Space Lasers. Please join me in welcoming Dr. Matthew Fagan.
Thank you, Megan. That was a really good introduction. Let me share my screen here. Okay, can everyone see that? All right.
Yes, I can see it.
If I get distracted at any point, I just noticed a very large spider. I'm sharing my office with a large spider. Chris, if you're on the call, you'd be appreciated. I had yet to kill the spider despite it jumping on me last night. I'm a little twitchy. Today, I'm going to talk about something that's kind of near and dear to my heart, which is about forest degradation, and restoring a degraded planet with ugly maps and space lasers. And I will say that space lasers will come at the end because that's where I'm going, not where I am. And I think of this as kind of a, what have I been doing the last 5 years and what will I probably do for the next 5 years sort of talk. So I'm going to give you a brief overview of a kind of a chunk of my life. And I thought I would start at the beginning, which is for me, second, I got to figure out how to advance slides. Central Texas. So this is a Landsat false color image of Central Texas. You can see Austin's labeled and the hill country to the west of it. Anything that's blue in this image is city, more or less. There's some bare exposed rock, but it works out pretty well. And it's a place where I grew up. I grew up kind of in western Austin in the hill country, and it was a place of rare beauty. So that's what it looks like. And this is karst country, so there's lots of collapsed caverns and holes full of bats, fields full of wildflowers every spring, and lots of beautiful, clear rivers that are beautiful for just and really warm and nice and just a great place to grow up. And I moved there. I mean, in Austin when I was 1 year old in 1985 when we really moved out in the hill country, and it was just really lovely. But it soon became the best place to live in the country. Everyone's heard of Austin at this point, and it was in the top 10 fastest growing counties were right around Austin for several decades, 2 decades. And so I watched this beautiful place begin to fade. Oh, and if I stare off to the side during this talk, I'm looking at my notes. Here's it in 1985, and here's it in 2021. Let's just go back and forth. You can see there's a lot more blue. And that blue looks a bit like this, and lots of that, and lots of this. In fact, this is an area that when I grew up was entirely unbroken hills with one building. And so good things are still left, but it's a little bit of the ashes of what it used to be like. So in those ashes, we still have things like the Barton Creek salamander, which I show here. It lives at about, starting about 10 feet down, which means that this very popular swimming hole, the Barton Springs, which stays 68 degrees year round, is also home to the only known population of the Barton Springs salamander. It's an endangered species, and it's got a pretty robust population despite the fact it's a swimming hole. The burning area in the bottom of this slide is the Balcones Canyon Wildlife Refuge. And as part of this massive development that occurred in Austin, they created several large parks in Texas, which is almost unheard of. And they're managing them by burning to create habitat for the black-capped vireo, and also have golden cheek warbler populations and other species which are rare. So there are good things left in this region, but I definitely really take heart in restoring used land, because it's something that's really important to me, having watched the place I grew up in get degraded. So it's also one of the things I really like about Maryland. And I'm not alone in that, thank goodness, because seeing that this is a state that's really devoted to restoring a signature part of it really attracted me to coming to live on this side of the country. And one exciting thing about restoration is that the world is interested as well. So we're currently in the UN Decade for Ecosystem Restoration. It was 2021, first year. And leading into that, countries have been kind of engaging in this large sort of pledge bidding war to I'm going to restore 1 million hectares. No, I'm going to do 10 million. I'm going to do 30 million. And so all across the globe, countries have been committing, and they have this global goal of 350 million hectares globally by 2030 to be pledged for restoration. And they'll probably make it. And on top of all that, so as part of Bond Challenge, there's this initiative 20 million hectares by 2020. They hit that goal for Latin America. There's also no less than 3 different Trillion Trees organizations sponsored by different people. I show the signatures for 2 of them. You see WWF, WCS, BirdLife International. They have a Trillion Trees campaign. There's another one organized under the World Economic Forum. There are lots of organizations that are raising money to either plant trees or restore nature. And it's kind of having a moment right now. And there's an avalanche of positive press out there. I stole this slide from my colleague Karen Hall, who in turn stole her colleague at C4, and this is just a sampling of news articles that are talking about planting trees to help nature. And but it still leaves the question, but what and how do we restore, right? So restoration, in many people's eyes, who are not scientists, comes down to a poster like this you may see outside your classroom, right? Plant trees, save the earth. Well, the first thing I would point out is there's a real focus on trees in this broad international discussion, and this has not gone unnoticed. On the right here is the proposal in Africa. It's the Great Green Wall. And I see this regularly in Reddit. It gets posted, oh, isn't this amazing? They're doing this amazing thing. And then someone inevitably says, well, it's only 3% done, right? And it may never get finished. And why would you plant trees on the edge of a desert? And so on and so forth. And these debates start to erupt. So I think there's an interesting tension between the forest we need, right? The forest that we think we need, and the forests we end up creating and having a goal to make. And I thought I would just talk about first the forests we need, right? We need forests that serve many needs. The top right here, you can see a forest that obviously has a lot of carbon in it and has a lot of leaf area between the ground and the sky, so it really can soak and absorb rainfall. On the left, we need forests that support biodiversity. We need multifunctional forests that may serve people and biodiversity, but we don't want to leave the biodiversity part of the equation completely out. And on the bottom right, bottom line, there's a huge number of people in this world who depend on forests for fuel, livelihood, grazing, and we need to have more forests that serve all these purposes, not just carbon sequestering sponges. The forests we need can be quite ugly. They may not necessarily be beautiful. It's something we think of, oh, I need that forest. So on the left here, we have incredibly diverse dry forests that are really important for global species protection and for protecting soil and dry terrain. Young secondary forests in the road on the top right, I took that picture. It's a very hard road to drive down. I sort of must have slid down to the bottom and mowed my way to the top. That's all young secondary forest. And in Costa Rica, and like in much of Latin America, the word for this type of land is sucio, which is also the word for dirty. So if you are thinking about managing this land, it's not clean, it's not easy to walk through, it is treacherous, and you'd have to hack through it to get anywhere. And so it's referred as a derogative. And to the bottom right, this is a tree plantation, which has an abundant grassy understory. So this is an example of Selva pasture. And those sort of forests, right, because it's pretty dense tree cover, serve multiple purposes. Well, they're not pretty. And oftentimes the forests we need are not forests. The focus on trees blinds us to the multifunctional benefits of restoring other kinds of ecosystems. So on the left, we have a timber plantation, which isn't really a forest, but it's a native timber plantation and will allow the smallholder that owns this land to sell wood in the local market. On the top right, prairies, which hold a lot of carbon and hold it more reliably over the long term in areas exposed to fire than forests do. So why would you ever plant trees if you could just let the grass grow? And at the bottom right, seagrass beds. Seagrass beds export carbon to long-term storage in the deep ocean. They are incredible carbon pumps. So if we're serious about carbon, why are we constantly talking about planting trees when we should be thinking just as much about seagrass beds, which have been on the decline in many regions? But in general, because of this focus on trees, a lot of the forests and tree planting specifically, a lot of the forests we create are really simple. So you can see these two tree plantations at the bottom here, eucalyptus on the left, teak on the right. We also create forests inadvertently by making fire and overgrazing. And we end up taking really diverse savannas, which have existed for millions of years, and converting them into rather simple woody thorn forests, which have very few species supported. So there's different processes at work here. The forests we create often fail to thrive. So this looks amazing. This image is so beautiful. This is China, the western deserts of China, and their Chinese tree planting programs. China has some of the largest payments of environmental services to plant trees in the world, investing hundreds of millions of dollars. But this image I found on the internet is actually a complete made-up fabrication. So I'll show you the true image. That's what it looks like. So go back and forth, same guy on the bike. Oops, sorry, that and that. So this forest failed. They planted the whole area away from the road, not just along the road. And there's a lot of dead trees there. And this is a really common thing that happened when you plant trees in drylands. They're not going to do well. Even if you do everything to get them to survive, they'll never be large trees. They'll be shrubs. And lastly, the forests we create often replace better forests. It seems extraordinarily counterintuitive to plant trees to replace a forest, but that is commonly what happens even for restoration purposes. Now, this is a picture of an oil palm plantation. So this is for commodity production of palm oil, which is a common ingredient in pretty much everything, including shampoo and Dunkin' Donuts. Not that I don't love Dunkin' Donuts, but oftentimes restoration projects in, say, for example, Mexico or Southeast Asia end up planting trees. And to do that, they clear up the rainforest around the plantation, thus clearing rainforest for plantations. So why is tree planting in particular so fraught with controversy and bad practices? So there's a lot to say here. There's misplaced incentives, there's greenwashing, the lure of a simple technological solution. Planting a tree is a kind of technology. Ignoring the opportunity costs of planting, failure to communicate with or reimburse local communities. I could go on and on. But people are taking notice of this, right? There's been a lot of pushback in the popular press. Now, people are starting to publish nuanced articles about whether tree planting and other should count toward reforestation or restoration goals, and kind of the effects of all these ideas. Because these countries have committed to restoring millions of hectares, and half of all their commission is planting trees. So it's still something that countries around the world are thinking about doing over the next couple decades. Might do a lot of damage. And this is not alone. Again, this is the bad version of the slide, and you can sort of see people critiquing planting trees on multiple grounds. And I know I've sparred with different people about whether planting trees is worthwhile or not, definitely is. It's a more nuanced thing than just let's do it. It's not always good. And in fact, poor planning and a short-term focus can lead to really disappointing outcomes. So if you read a news article about Turkey planted the most trees ever in a single day, it turns out that of the 11 million trees they planted, 90% were dead within a month or two. And you can see in India, indigenous tribes class with the government over trees, tree planting efforts. Most tree planting efforts fail. And I think this picture on the bottom right is pretty dramatic. Locals in Pakistan uprooting trees planted by the government. So there can be a lot of local pushback. And so these top-down initiatives, country-level initiatives, end up running into local resistance. Because trees represent space that could be used for other things. So I thought I'd pause for a moment here and talk about this ugly truth and the utility of ugly truths and the utility of ugly maps. So I'm not claiming this map is ugly. The contrast, this map is quite pleasing. This is the Global Atlas of Landscape Restoration. This is the map that was produced by the IUCN and World Resources Institute, and it really sparked all those national commitments. That 350 million hectares that's going to get committed to restoration, half of it to tree planting, was sparked just by countries looking at this map and going, hey, I've got huge areas that I can restore. Anything that's in green here could be restored. So it was really inspiring. And I'm going to talk a little later about this map. But in general, beautiful maps like this run into trouble. And the way I'm going to give you a kind of a cynical take on this, which is conservation organizations recognize that success stories garner money and attention. This is something that it's a positive feedback loop. And beauty is part of that, right? So with enough money, you can create beautiful maps and create really nice success stories that push narratives like plant a tree, change the world, it's going to be good, doesn't matter, give us money. Even if those narratives are not fact-based, right? Even if they contain errors that may lead to damage further down the road. I'm not saying all conservation organizations do this. In fact, the authors of the study behind these maps actually are very well aware of how their map got misused. But the only problem being with that, right, is that we're going to waste money, waste effort, and then when there's a failure, so if we spend a lot of money, we're going to end up with some success story, but there's a failure, failures will get pushed under the rug, and we won't learn. And not learning is problematic because it means we make the same mistakes over and over again. So beautiful maps can be seductive and they can be misleading. But why don't we pay attention to all the issues that tree planting is going up and really collectively have a very nuanced understanding of where tree planting could go? Why isn't there a more complex discussion going on? One second, I'm clicking too many things at once here. So I think of this as sort of this picture, which is when I search tree planting is good, this picture pops up, right? And our goal with planting trees, our goal with restoring ecosystems is to make the world a better place. But when our outcomes are people getting pushed off their land, all the trees we're planting dying, or planting over on top of rainforests to plant more trees, there are reasons why these goals don't align with our outcomes, and they can be rooted in bad science. And I think bringing these reasons to light is the first step towards learning from our mistakes. And it's absolutely vital to be constructively critical of restoration efforts and plans, because I think everyone that goes into restoration has the best of intentions. But I would argue that alongside really good ecological and social science, the new satellite aerial observatories, which may allow us to make really amazing maps, they're crucial to this task. And using them well is really important. So let's see. In part here, it's not just social issues. It's not just programmatic issues. It's not just communication. There's also insufficient knowledge. And that's part of the problem. So how and where forests should be grown in landscapes is something that people need to know on a very granular level. But oftentimes our advice is kind of like this diagram right here, which I actually really like because it's very pretty and it's showing you that there's cropland and then a shrub zone and then a gallery forest zone. This is standard USDA conservation recommendations for how to buffer a river, which is on the left-hand side here, from the effects of nearby cropland. So this is a riparian forest along a river. It's been planted or let there to sort of protect the river. And you can see they're showing you water quality as red in the cropland, yellow in the shrubland, and then green by the time it gets to the river, which is a really good thing. And in the US and in developed countries, I believe we have more information about how and where to plant trees to protect water quality supplies. But when I look for papers in the tropics, especially, or really detailed questions, you see publications from this year, last year, or nothing at all. And just to give you some question examples, what is the width of riparian forest that would be needed to allow keystone organisms like rainforest monkeys and birds to pass through this riparian forest? What's the opportunity cost of this little buffer here for the farmers? How much of a tropical river needs to be clothed in riparian forest to maintain water quality? I've seen papers on that from 2021 and from one country. There's a lot we don't know. It's really important. And there's just simple questions. So it's one thing to take a principle as embodied in this diagram and then apply it. You need details about what to do. And right now, I think a lot of tree planting is done in the absence of a really detailed set of recommendations. But I will say that certain countries, like in Brazil and the Atlantic forest, have been actively developing those recommendations for their own scientists. So it's not applying uniformly across the world, but it's really exciting to see this field starting to burgeon. So I thought I'd just run through kind of a list of ways in which I try to answer questions around where and how we restore land. And I thought I'd start with kind of 2016, when I first arrived at UMBC. I was finishing up the last paper of my PhD. Now, this is the San Juan La Selva biological corridor. It's in northern Costa Rica. The Atlantic Ocean's off to the right. This is also the first of the ugly maps. So I made this map as like the culmination of my PhD. I was very proud of it. It wasn't until I was teaching 386 years later, and I was like, oh yeah, that's a really, the student showed up on the slide and they smiled. And I was like, it is kind of an ugly map, isn't it? In that it's hard to really know where this map is. There's all sorts of reasons this map has issues. But I feel like it's really useful. And when I took it around to talk to people the following year in 2017, I took this map around and I learned several things about how this map could be used to support conservation and how this map had problems with it, which I'm happy to talk about later. But what it's showing is basically areas where we don't want to cut down trees, because if we do, connectivity will drop, and those are green, and areas where we might want to plant trees, and yellow and red. And what I learned by studying this corridor is this is a zone where they're focusing lots of money to plant trees and lots of money to protect forests. And forest cover has stayed stable over time, holding back agriculture expansion, which has been rampant. It's where a lot of banana and pineapples produced. But during the 25 years that I studied, connectivity before and after the corridor has gone down. It's gotten harder and harder to get from one patch of rainforest to another, as the agricultural valleys, which are kind of these yellow and red slashes here on this map, have been developed. So this corridor, nominally established to maintain connection between the forest in Nicaragua in the northern part and the forest of the mountains in the southern part, is becoming increasingly disconnected. I communicated that to the government, and we talked about how they're thinking about prioritizing areas here, but I also learned how difficult it is to actually change programs once they've been created. It was educational. To fast forward to something different, I thought, oh, I'm going to study an area of the US. And I randomly picked the southeastern US. I could have picked the eastern US. And I wanted to study how fragmentation is affecting the structure of those forests. I made the mistake of picking the southeastern US, and I quickly realized that most of the southeastern US is planted. This is the second ugly map I created. This was 2 years worth of work, and it's not the prettiest map. I think pink was a poor choice for plantations. But what you're seeing here in the area inside the black thing is basically the first map showing where people have planted pine plantations across the southeastern US. And there's a very small picture of one on the right. So these are monocultures of loblolly pine for the most part, planted for timber and lumber. And they are cut down every roughly 5 to 14 years, depending on where you are in the southeastern US. So there's just a lot of them. It makes up about a third of the forest. And what that means is that the natural forest in this region is much more fragmented than we thought. Of course, the area of core forest declines by about a third, as you might expect, but the fragmented area of forest goes up by about 50% when you remove the pines. So for species that don't, say, like being in or near pine forests, of which there are several which are threatened in the southeastern US, they're much more fragmented than previous forest maps have been indicated. So I got excited making this map because I was actually able to map plantations of trees and then use it to look at what had happened to the landscape and whether conservation programs were needed. And then I ran into a paper basically saying that plantations are terrible, plantations are awful. And of course, my mother would laugh. I tend to always reflectively defend something. And sometimes I tend to, and then I sort of have to be turned around to agreeing with the thing I liked before. And of course, I thought plantations are bad, but bad for certain reasons. They're good at growing, they're good at producing wood, and yet there were these large meta-analyses published in good journals saying that natural regrowth was accumulating more carbon than plantations. That in the case of the article on the left by Renato Cruzio, that natural regrowth was better at everything. So science advances, it's better at biodiversity, better at carbon, better at water. And it just seemed puzzling to me because so many times I'd seen scrubby natural regrowth and plantations start growing very fast. And in discussion with Leighton Reed, we realized that all these studies, and there were actually three that reviewed, three meta-analyses, they all had the same problem, which is that people plant trees everywhere, from mines, which would be the area in red over here, really poor quality sites that are just terrible, to really fast growing sites that have only been lightly touched by people. But they don't, forests don't regrow everywhere. There's plenty of places, like for example, old mine sites where regeneration is just stalled and nothing regrows. So there's this like pre-filter prior to the science happening where the good sites grow in a forest, the bad sites stay out of forest, they don't get included in the study, and the planted forests are across all of it. So of course natural regeneration looks better because you're looking at the good natural regeneration. And actually people have done studies looking at natural planting trees or letting sites go basically across the entire gradient, and they find that plantations grow faster, at least in the early stages. So this was a fun paper. We got it in a good journal. It was 2 pages long with one graph. And then we were having so much fun working together, we decided to ask a different question, which is how long do regrowing forests stick around, right? So is restoration even worth it? If restoration better or worse, is it worth it? And we looked in southeastern Costa Rica in an area around a park, which is a little pale green area here. And we had this long time series of high resolution imagery that allowed us to watch forests regrow and then date how long they lasted after they regrow. Farmers were constantly clearing this landscape. And what we found is that if a patch regrew, about 50% of patches were gone in 20 years. And then by 50 years, which is the longest time we had between our aerial photos, 80% of the forests that had regrown were gone. And that sounds very dramatic because it means that if I let a pasture regrow or an old coffee field regrow, chances are only 1 in 5 of those pastures are going to be there in 40 years. Now, that's actually really good, it turns out, because if you look at the paucity of other studies in other countries, their averages are in the 5-year range. There's only been a few studies like this. This is one of 2 when we made it. Now there are 3, and it's not very long. Secondary forests tend to be, as farmers often think, sucio, something you don't want because it's occupying your land. You can't plant crops there, so they get cleared quickly. So then I was working with Leighton, and I was thinking, oh, wow, all these restoration, people committing to plant trees or to let their forest regrow, they're really ambitious. Are they going to meet these goals? And so we looked at the area of basically permanent crops and plantations, and then the area of their restoration commitment. So how much, if you want to think about it, planting trees have they done? That's on the bottom x-axis. We looked at a bunch of factors. This is just one. And then how much did they commit to do more planting and restoration? And you can see there's a positive correlation. So countries like China and the US and India, they have a lot of area already planted, and they felt confident they could plant more, so they committed to plant more. But there's this kind of off the x-axis, there's a bunch of red countries. And these are countries with relatively low development indexes. So we used unsafe water mortality because it was a really good predictor in this regard, but we looked at others. It's all kind of tightly correlated. Essentially, countries that did not have a good record of providing services to their citizens because they're often poverty stricken, were actually committing more area than might be expected. And this is actually just one axis of a multiple regression. And that was very consistent. So we found that these poor countries might be doing this for many reasons, include just basically saying, we're going to be really ambitious because we live closer to the land. And I should say, and we're going to be more affected by climate change, so we're going to take this problem seriously. Or potentially because they don't have good expert knowledge to tell them these commitments are not good, or that they know these commitments are too ambitious, but they're doing them to attract funding dollars to, say, make the commitments happen. And this paper was with some UMBC undergraduates and Dr. Maggie Holland. And we also did our part of this paper. We looked at the risk of countries to not be able to successfully restore their land, which there were a variety of risk predictors. This is just an indicator on the bottom right. And indeed, we found that countries that were lower deforestation rates, greater rule of law, were actually much closer in the reported progress to actually achieving the restoration commitments. So like Costa Rica, Pakistan, Brazil, Costa Rica, and the countries like Cameroon, Malawi, and Rwanda, which had made very ambitious commitments, were much less close to achieving their goals. And then I thought, there's a lot of restoration going on in the world. I wonder how existing global forest maps could guide all this restoration and tell us if things are going to work. And I focused on this one, which is by Hansen et al. And what you see here is intact forest in green, forests that have been cleared during the time period they're studying, which is usually from 2000 onward, are in red. Forests that have been planted and cut down at the same time are in pink, and there's some blue in here, but you can't see it. That's a forest that regrew. This map has been downloaded 5,000 times. It's been brought into the Global Forest Watch. They changed the color scheme, talk about ugly maps, but the blue there is, we're looking at Africa now, and that's some regrowth in Africa. And the Global Forest Watch app has been used to basically monitor deforestation and inform conservation around the world. So it's a really powerful set of maps. And we looked at it in Costa Rica, and we thought, how well does this map do in predicting forest cover and forest fragmentation? And we found it doesn't do so well when you get outside a humid forest. So what we're seeing here is forest cover in green, non-forest in gray, and red and purple are mistakes that the map makes. The red is agricultural areas that are being called forest. So all these plantations, banana, sometimes sugarcane, sometimes rice, it was making mistakes in areas that were very green. And the purple are big areas of tropical dry forest, which is 100% tree cover, but it leafs down in the dry season. And the map was basically seeing down in the understory and saying, oh, it's clear, and marking it as pasture. So this map works really well, but not in areas that are dry. And I thought, I just read a study that did that. And I looked at a global, so there were two major maps of restoration potential. One of them is that Atlas of Global Reforestation Restoration I showed you before. Here is another. And they use global forest maps to highlight areas where tree cover could be higher, to basically focus money into countries where they think they can plant a lot of trees. But these red boxes describe areas where the tree cover is actually higher, much higher than predicted by global maps. And actually the entire, so everything that's green, this is actually not the map of restoration. I think I picked, this is the map where we're under predicting tree cover. So the global restoration map saying plant trees here, but in reality, there were already trees there. It's just the satellite missed them because it was too dry. So what this does is encourage countries who are in dry biomes to plant trees. But we know that's a bad idea because most of those projects fail, and they also increase fire risk. And so it's a really set of bad incentives driven by the maps themselves. And these maps directly have affected policy. So I thought, okay, I've been critiquing maps for a while. Why don't I see if I can make a better map of planted trees? So I collected together some satellite imagery and some microwave imagery. And you can sort of see that if you look at it from just a color standpoint, this is a false color image, the whole thing is green. But if you look at the right-hand side, all that pink area is oil palm plantations. So you really can pull them out if you bring in more data than is currently being used. But it's easy to do that locally. It was harder to do that globally, but we made it work. So this is a paper I have in review. I just submitted it yesterday, resubmitted it. And it's a land use map where I take every patch of regrowth between 2000 and 2012 that was identified by this Hansen Global Forest product. And I separate it into two classes, natural regrowth and tree plantations. So basically planted in rows. And you can sort of see that there's a lot of tree plantations in Brazil, a lot of them in Southeast Asia, and not so many in Africa. However, in Africa, there are more than you would expect. So this map, because it's highlighting edges, it actually makes them look like there's a lot of natural regrowth. When there's by area, they're about equal. So this is what we found after doing this study, that although the FAO says that tree plantations are about 7% of global regrowth, in reality, if you just look at this decade, they're about half global regrowth. So a lot of what we think is regrowing naturally in the tropics is actually just a form of agriculture, tree crops. And to zoom in, this is where I'm going to go fast. Here's Latin America, just kind of showing you areas, and you can see little patches of red kind of scattered throughout. And here is, so I put little one focal area in Brazil. These are protected areas, which are just overrun with eucalyptus plantations. And this is what a eucalyptus plantation looks like on high resolution imagery. Just looks like a billiard ball. In Venezuela, you have protected areas which you have oil palm encroaching into, right? Oil palm tends to look like a honeycomb. And we basically found about across the humid tropics, when a protected area was accessible to people, about 1 in 5 would have a plantation inside of it of some size. And in Africa, there's a lot less, but when you zoom into particular areas, like just outside a city in Nigeria, we have 2 highly protected national parks. These are protection level 1 and protection level 2 in the IUCN, and they have rubber and oil palm inside of them expanding. So Africa was actually the saddest part for us because we saw just a lot of this happening over and over again. In other parts of Africa, the plantations were maybe originally planted to help the local economy, but they are nibbling into the edges of the national park. Here's just a plantation on the outside of Nat Kenya. So this is potentially a protection plantation, so it may not be a super bad story. So in Asia, we see lots and lots of plantations. It's known to be a center of expansion of both rubber production and palm oil production. And that dominates huge areas of Southeast Asia. So just zooming into Thailand, here's a highly protected preserve in Thailand that has rubber nibbling into its edges. And it's quite dramatic because it's leaf down, so it looks very, very different. And we found in Thailand, which is, I picked it as an example because it's known for how well protected the parks in Thailand are. Here's a reasonably well protected, like level 3 wildlife preserve in Thailand, and you see the red coming into it, and that's all oil palm kind of rolling in. So there's a mix of oil palm and rubber in this landscape. So there's just a lot of encroachment in areas that I didn't necessarily expect when I started this study. So that's the melange of questions that I sort of rattled around in over the last 5 years. And I have some big questions remaining. I thought I'd just quickly tell you about them. And I did promise to talk to you about space lasers. So those of you who signed on hoping to see a space laser centric talk, you're going to have to wait a couple of years. So that's where I'm going. It's not where I am right now. But the first question is, across the world, where do forests persist, right? Not just natural forests, where do planted forests persist? In answer to that question, I'm going to use existing maps, like this map I just showed you. I already have a paper started on that, and develop some new maps where we're looking at relative persistence. So we can think about it. If we want to have a forest regrow or to plant a tree, where should we do that to maximize the chance that it's going to stick around for 50 years, 80 years? Second, I've been thinking about this question for years, which is, can tree planting buffer nearby native forests? Can we just plant trees around a forest to protect it? And I'm answering that with aerial LiDAR imagery in part. And then I'll be looking at narco trafficking in Central America protected areas. And the reasons for that will come obvious hopefully in a few slides. But part of that, we're using space lasers, and we're just starting, which is very exciting. My PhD student Hassan And my colleague, Steve Sesney, and I are all digging into this starting this month. So first question, do new forests persist differently across continents? Do they persist differently across aridity gradient? Are forests that regrow or that are planted, are they more likely to burn? We say they are for planted forests, but what about natural forests? What about societies? Does population density correlate to how often forests get recleared? Does having a denser society lead to more caretaking and less fires and thus more persistence? And actually, that latter possibility is probably the more likely one based on the data. So that's the first question I want to answer. And so one of the papers is Uriarte has been working with the data I showed you before, and we started working on that paper. And I'm advising a PhD student, Pedro Pfeiffer, which is going to examine that question in Brazil, looking at planted trees as well, which will be a lot of fun. Now, whether forests would benefit from having green belts around them, green belts have been around a very long time, but they're primarily used in agricultural land. So the idea is that, wind comes along, hits a forest, and there's a zone of protection. We know it extends roughly 20 times the height of the trees. So if we want to protect forests from fragmentation and trees falling down and edge effects and make them cooler, more inviting places for wildlife to live, should we just surround them with trees? And I actually read an article, I've read one, that looked at this in New Zealand, and they said it does make the forest cooler, which is kind of exciting. And we know that there's edge effects in forests, but the distance of these edge effects is quite variable across space. And people have been studying edge effects for decades. So when the accompanying graph to this little image on the bottom says edge effects will penetrate between 30 meters and 775 meters. So between a stone's throw and half a mile. And I'm like, that's a lot of difference. So long story short, I think we can do better. I think we can predict edge effects. So if you want to know whether we should plant trees around forests, let's just start with the idea of, well, we already have forests around forests, right? The first 50 meters of forest could be the planted. And let's go inward and see how well that's protected and how well we can predict edge effects. So I started in Costa Rica, it's the first study, and we're going to continue this study in Maryland. And hopefully Megan will be interested in working on this, but I think this is going to be some really exciting work where there's just a lot of LiDAR data. So this is tree height, and you can see blue trees are really tall, black is the ground, and red trees are kind of short. And this is a nature preserve called the Selva Biological Preserve in Costa Rica, and it experienced a massive storm. Let me overlay the drone imagery that we took. There we go. All that orange got blown down. Is it near the black edges? Slightly. That's what I'm seeing in the statistics running this. The edges are important here, but they're not the most dominant factor. That actually, when very large storms come and hit forests, it looks like edges don't really protect forests from large storms. We know that they can be protective from smaller regular storm events. So this is just one more piece in our knowledge about this. But this is going to be fun, super exciting, and we're going to be looking at this exact same question across Maryland. All right, so finally I come to the last of the space lasers. So one of the reasons I'm really excited about this project, which is going to work with 3 protected areas all across Central America, is that we're going to be looking at the long-term impact of small clearings, so small airstrips, small roads for narco-trafficking, and how that affects neighboring forest degradation. So it's kind of on the low end of disturbance. These are things people do in secret to not be detected by satellites. We want to see what the effects are on the forest over the long term. And what's interesting about this is, especially in Guatemala and Honduras, we're going to be working with space lasers to make this happen. So there are multiple ways to take LiDAR data. One is from a plane, a drone, or from a satellite. And you get this really cool picture of a tree. So all these graphs that show you kind of the laser response, you can sort of see, hopefully, a tree and some shrubs in the ground. And that can tell you how tall things are, whether it's sparse or dense, and whether or not the forest is intact, like on the left-hand side, or heavily degraded by disturbances on the right. And one of the fun things is we could just do this with space lasers, but we can actually tie it to actual ground data, because where we're working is the set of Star Wars. One of our field sites is the same place that they filmed the moon base, so they're trying to destroy at the end of the first Star Wars movie. And they have aerial LiDAR for the entire area. So we're going to get pieces of this aerial LiDAR and be able to connect it to what the space lasers are telling us, and then use that to map degradation across all of Central America. So we're very excited about that. And then I'll I just close because I'm getting short on time and I knew I would be. All these questions that I've had and all these questions I've talked to you about today presuppose that answering them will make a difference, right? Um, this is where I wanted to look at my notes because I don't want to be too doom and gloom here. But I think it's important to remember that we find ourselves in an inflection point in history, right? Hopefully you've seen this amazing graphic before. I did not make this. But climate change is coming. Change is coming. Change is scary, and society will change. The world will change, and it's pretty much inevitable that beautiful things will be lost. And I strongly believe that how we respond now, whether with apathy, with fear, with passion, with kindness or hope, it all matters. But this is key, and it's a key but. We do have time and ability to make changes happen, to save some of what we care about. And I think science is more important than ever. And I was thinking, there's all these things, it takes faith to plant a tree. And I think it takes a certain amount of faith to study people who plant trees and think those studies are going to make a difference. And I hope I've convinced you in this talk that all these observatories, which cost billions of dollars of your tax money, aren't just there to chronicle a meltdown. They're crucial to conserving and restoring nature through the next 100 years or so. And ugly maps optional. Hopefully people will come along who are better at communicating this. And our lab is working on this, but it's just one drop in the flood of new research, and it's a joy to see. And thank you for coming to sort of my talk. Questions?
Thanks, Matt, so much for a really, really fascinating presentation. Before we go to questions and answers, I'll just mention that I had a request that could you provide links and references to publications on this topic. So I don't know if you would be able to field questions while putting links in the chat, but if not, you can send me something and we can send it out to the mailing list.
It might be easier to send it to the mailing list. I also can, when we post the recording of this, and if there are people, I'll post it on Twitter as well, and I'll just put whatever I send you, Andy, I'll also put it on Twitter.
That sounds good. So for people who have questions, and there's a couple up here already, we're going to call on people in the order in which they posted their questions in the chat. Basically, what we'll do is we'll call on you in that order and invite you to unmute and actually ask your question. So there's some direct interaction. It's not all completely virtual. And so we're going to start with the first question, which is from Bella Dastan.
Hey, Bella.
Hey, can you hear me?
Yeah, I can hear you fine. How you doing?
I'm good. It's good to see you again, virtually. So I just wanted to first say thank you for presenting. And I was curious if the research project you've previously mentioned about examining the forest gaps between like fragmented forest is in relation to one of your big questions about trying to see if planted trees can help buffer native forests. And I just want to know what your progress was on that research project.
Okay. So thank you for the question, and thank you for coming. I rushed a little bit at the end there because the connection is actually kind of fun. Because as my friend said over beer one evening, he goes, Matt, you don't need to plant trees to know if planting trees would be good. You can just look at the outer part of the forest and see what it has done. And what we find so I've been looking at this in the southeastern US, and what we find is there's an effect, but it's small. And it's hard to tell if that effect is due to the trees going up and down, being cut down. It may be that having trees, there is a very clear effect of having trees around you, that there's an edge effect, and that edge effect can penetrate very far. So the trees continue to get taller and taller, and the canopy gets more and more intact. As you move away from the edge, the biggest changes are within the first 50 meters, but it continues to happen at a slower rate, hundreds of meters into the forest. So it's good to have trees planted around you. Now, I don't know yet whether it's good to have trees around you that get cut down every 20 years. So I think of this as like the Lucy effect, when Charlie would go to kick a football and Lucy would pull it away and Charlie would fall down. So it may be that we're helping forests in the beginning by planting trees around them, but then if we then cut those trees down, we're exposing forests and they're not ready for it. And they're more likely to fall down and get degraded and have lots of gaps form. So I know the first is true, and we're going to be publishing on that in the next year. The second, we have data for it. We just need to analyze it differently. And that's going to take me probably the next year and a half to give the answer to that question. And I think it's worth looking at across multiple different systems. Thank you for your question.
All right, thanks. So the next
Thank
question
you.
is from Leah Stout.
Hi, Matt. Can you hear me?
Hi, Kaylee. How you doing?
All right. Good. I'm doing great. Good to see you again. Okay, my
Good to see you.
question is, you mentioned in your talk about planted forests that were planted for conservation and then other forests that were planted for plantation um, reasons, and you talked about how the plantations tend to have a higher success rate than the planted conservation forests, and I was curious what you thought the main factor for that would be. Why plantations, although they do get cut down, but why do they have a higher success rate off the bat than the conservation forests?
So the conservation forests are naturally regrowing, and so they get established slowly, and they don't grow that quickly because they are not planted. They're not planted at a certain size, right? They have to root. There are site amendments, and site amendments. Sorry, I'm using forestry speak. They fertilize them sometimes. They clear the grass around the things planted. If a site is tended, like if it's going to be for money, they've got the process down. So they may spray herbicides to keep the understory down while the other trees are getting started. So that, especially when you're looking at these really broad studies where they're bringing in studies from a lot of sites, is basically what's happening. And that because we are planting trees that are healthy and treating the site to take care of those trees when they're young, that leads to a pulse of quick growth. So they accumulate carbon more quickly. They don't accumulate biodiversity more quickly, though they can accumulate a somewhat biodiverse understory. Typically, the natural forests surpass them pretty effectively over time. But one thing that happens is if you have a relatively good overstory and a relatively good understory, as happens in some plantations, that's a lot of leaves between the sky and the ground, so they can protect slopes quickly. In many cases, like for example, in the Atlantic rainforest, what they're doing is trying to encourage farmers to plant eucalyptus, which is a non-native tree, and then let whatever grows in stay. So the farmers get wood in 20 years, and meantime, birds have been landing on the eucalyptus and making an understory of native shrubs and trees. So that eucalyptus, when it's cut down in 20 years, they leave whatever's left, and they have a native rainforest growing there. So instead of it just being lost land that they're never going to see money from again, that may take a while to get big, they get an instant forest that then is converted to a native forest, and they can get biodiversity payments from that point onward. And that's a really exciting idea, and my colleague Pedro Bencalian's been really pushing that, and I think it's really taken on outside the walls of academia, so it's kind of neat to see. So I don't know, some of these plantations I mapped around the world, some of them have very good conservation uses. They're there to protect the watershed. It's not always negative if there's a plantation in a park. Unfortunately, things like oil palm are really common in parks, and they don't really have a good like conservation use.
Okay, thanks. So Earl Ellis has a very short question, but we'll go ahead and have Earl ask it. You're muted, Earl. Still can't hear you. Earl, you're muted. All right, let's see. Did that?
I'm sorry, I have multiple devices here. Sorry about that. So this entire presentation is wrapped around a narrative of we need, we see, we plant. I think that is, I would like to hear you explain who is we and unpack that a little bit, because it strikes me that without asking and trying to answer that question, it's not really clear what these forests are doing.
Well, I thought I totally agree with you. I think the social science behind reforestation has A, been neglected, and B, been largely ignored even when it's pretty solid. And I talk with my colleague Forrest Fleischman about this quite a bit, and he finds that by and large, even when they make recommendations, they get ignored. And let me answer this more broadly. The we in this presentation, I intended it to be just what humanity does and what humanity largely needs. But the difference between what a local community might want to do with their land and might have needs, and what these upper level conservation organizations who are maybe trying to get carbon offsets to serve first world developing region offsets, totally different directions. And the conflicts, the failures in reforestation from that sort of different levels of different ways of thinking and management and being sensitive to local needs, a lot of them arise from that, these sort of top down versus bottom up differences. And one of the things I find, and I think many people find really annoying and alarming, is that the greatest practitioners of restoration globally are indigenous peoples. And yet they don't really have a voice and are not recognized for these activities at these upper level conservation trillion trees organization levels. And so there's a lot of energy and money being sucked up here and a lot of activity going on here, and the two are not necessarily meeting as effectively as they could, or really in certain times at all. So it was a fictional we to allow me to talk about this topic without breaking it down into a very complex set of social interactions. And I think you're pointing out that it's not one unified we. That's a big part of why a lot of these programs fail.
So a short question turned out to be a really important one.
As usual for Earl.
So we're just about out of time. It's 12:58. If there's any last question anybody wants to pose, now would be the time. If I don't see one, I will ask one. But
I'm glad to follow up on that question.
Okay, go ahead.
As somebody who's very guilty of talking about humanity, right? That's something that goes on in my work often. But I find that without intentionally interrupting yourself every single time you use the term we, and deciding who are you speaking of, speaking for, who's being silenced or left out, and what does that matter to the knowledge that I'm presenting, and what consequences will there be for some people? I feel like that's poor science if one is not doing that. I feel like this appeal to a kind of humanity without a questioning of what does that actually mean for the science and knowledge that's being provided. I think the consequences can be quite negative. Scientific information doesn't have to be produce a better outcome necessarily. It can often produce a worse outcome. And so I think that's a very important concern with all scientific work that has policy implications like this, or decision implications like this.
Yeah, I think it's a good critique, because I think I said we need more science, right? But I think the problem is that the people can emphasize different parts of science, and there's science being produced in service of certain narratives right now. And I didn't want to get into the weeds and sort of point out which exact studies that have been criticized by other scientists as being politically motivated or motivated to get funding.
Well, you also said we need more trees.
Well, no, that was a narrative, right? The idea that we need more trees. We need certain kinds of forests, and really we don't necessarily even need forests. We need ecosystems, because there are ecosystem services that are being lost, right? There are things that would serve humanity, but that's just very broad. And
carbon sequestration doesn't serve humanity. It serves to justify carbon emissions.
Totally, but
it doesn't serve anybody else.
But in that little slideshow I had, I tried to put people, this broad carbon market, and then biodiversity as sort of three broad areas, but I wasn't diving in the weeds on that because, as you're pointing out, there's a lot there. And I did bring up, and I hope I brought up, when I think conservation organizations are looking to manipulate our desire to restore, right, in service of their own good, and our being their funders. And their funders, broadly speaking, are usually developing world populations. So, yes, I completely agree with what you're saying. I hope I didn't give the impression that we need these things because I need these things, or that, but I think that we need trees for me was just saying that this is a narrative that we need trees, we need forests, what we need are ecosystem and social, we need ecosystem services that serve people as well as the planet. And I'd say if you ask local communities what they want, it could be they want to plant trees. It could be they just want a better division of where their grazing grounds are.
Well, most communities will have diverse wants and needs.
Yeah, exactly.
And that's typically true of all of these kinds of contexts, is that there's not one thing going on with everybody united in one perspective and one set of needs, etc. I'm just proposing that you yourself would actually find this a very productive avenue to examining what types of knowledge creation that you're doing and how it's presented in such a way to actually, what are the potential impacts of this for different people, not just for a kind of science is good, humanity needs science, therefore, right? So I think that's an important element, and I think it's very productive for your own work. It increases citation rates to be more actionable.
Well, thank you, Earl. I think coming from someone who's made a very influential global map, I will definitely think about that, because this is my first global map that may get published, and I'm a little scared, to be honest, of how it might be used, because I've seen global maps be misused. So yeah, thank you.
I think this is a very interesting note on which to close this, and I'll just mention to finish things out. I think, Matt, you made the point earlier that the maps that are out there often drive policy by how they're used. So I think this consciousness of how the science may affect policy and the question about who benefits from whatever measures are taken, I think is a really important one. And so I thank both of you for that part of the conversation. We're going to go ahead and stop the recording now. We're going to thank everybody who joined us. Matt will provide some links. We will post the links along with the video when we post it. So, oh, and the last thing I'll just mention, because I forgot to mention it before, is that next week, same time, same place, we have a presentation by our own Dr. Jeff Halverson on a topic called The Summer of Flash Flood Disasters in 2021, the new normal in this era of climate change, ? So with that, I'll stop sharing and we will close the recording. Thanks everybody for joining us.
Thanks, everyone.